Well, hi, and thanks for joining me here in my shop while I go another stage with this radio, which is working really quite well at this point. But, it's Christmas Eve. It's December 24th, and I've got about an hour here to work in my shop before I have to return to real life. So I think what I'm going to focus on is this screw and this capacitor. When I did the alignment, I discovered that I could not generate a peak by adjusting the trimmer here, and I'm curious about that. I've encountered this so many times, and I've just kind of blown it off and moved on, left a lot of radios with this cranked right out, same as this one arrived. This one arrived with this trimmer cranked right out. So I've been thinking about this a little bit, and I can only guess that some kind of additional capacitance has worked its way into this circuit. I don't know how. I haven't really read anything about that, but I'm sure other people have explored this question because I found it so many times on so many radios. There must be something going on as a radio ages that ends up changing either an inductance or a capacitance somewhere and changes the resonant point of this part of the circuit. So the fix on that would be some kind of compensatory thing, add more, remove some capacitance, or do something like that, I guess. I don't really know. I'm just going to explore this whole question. So I think the first thing I want to check is it really true that there's no peak there? And what enters into this picture now is a complicated combination of the local oscillator setting here and the pointer setting on the front. Kind of all plays together. Talking about playing, let's play the radio. And we'll check on this. So I'm hoping to use the sweep generator for this. I'm not quite sure how I want to approach it, but you can see I have a loop just clipped onto the back of the radio, and this loop is somewhat messed up. Here, this loop is simply going up to the sweep generator that's sitting here. Okay, radio, where's the sound? There it is. Oh, what was that? What was that? So there are some funny things happening with this radio, some intermittent stuff. I heard the radio just drop right out and come back. Oh, there we are. A little bit of a problem with this tube. Okay, but I'm not going to focus on that. You can see the light. Now, what tube is that? That's the rectifier tube. Okay, back to this guy. Just listening to the radio, I'm going to turn that. Sometimes when you're using instruments, you can see variations in the instruments. You can see them vary a lot, and you might think, oh, that's varying a lot in terms of the radio operation. But in fact, the radio operation may be, to your ears, may be varying only a small amount. That's a little too big. Let's try this. A little too much metal there. Now, I'm not using any instruments here, just listening. So, not much difference there, right? Went down a bit as I tightened it right up. But definitely no peak appearing. Tune down this end of the band here. What's that? I have a new piece of equipment in my shop here, nothing to do with the shop. It's a router. And I'd love to unplug it right now, but if I did, my computer would stop. No, it wouldn't. No, it wouldn't. I could continue the video. Is this from the new router? Oh. You know what? I'm not going to fool with it. Let's carry on. But that's a new noise. Surely that's not... Oh, you know what that is? That's my sweep. Yeah, sweep generator. Cut it off. Okay. It's 590. See if we can hear a peak here. No. Now, I think the instructions for adjusting that actually have you doing it way up at this end of the band. And I'm pretty sure we're not going to hear any stations up here. Is it the tube doing that? I can see the light flick on and off. Okay. Focused on this now. Did I hear a station in there? Okay, well, we're going to have to hook up. We're going to have to get a signal generator going on this to do this properly, because there's no stations up here to listen to. And I got to hook up some instruments anyway to make more quantitative measurements of what's going on, since the variation seems to be very subtle. I'll get all that set up here. I was busily hooking up this meter here to measure the AC signal reaching the speaker when I noticed that hey, I already have some meters here. So this is a little more of my audio system here for making videos. These two meters, I keep an eye on them. They're sort of averaging meters, so you can see as I talk, they're moving up and slowly coming down. This red thing here is a little more like an instantaneous peak indicator. I try to keep my eye on these things while I'm making the videos. But the fact is, this can be used as an instrument, because the sound from the speaker is going in my microphone just up here, showing up on here. So for instance, I'll just be quiet for a minute, and maybe you can just keep an eye on this meter. Voila. Just incidentally, just because I've gone this far into how do you do video sound, the actual software, you can see here on my computer, has a sound bar indicator there, or level indicator. So that's the real one. That one tells me the real truth. But anyway, so that's great. So we should be able to do this just by watching this meter, which you can't watch now. Let's go up in this world. Come over here. And we got a big reflection. Where is it coming from? It's coming from here. Okay, so a little hard to see, but I can see quite clearly what this meter is doing. So we will tune this in as accurately as possible first. Okay, that's it. Now we're going to move this. I'm doing this at 1500 on the dial here. 1500. Just come down a little wee bit. 1500. Right now the capacitor is wide open. Okay, I'm watching my little volume meter here. Going down. Oh. I've got these meters heavily damped with a capacitor, so it takes a long time for them to settle in, but in fact, there's a little bit of a peak way out here. Way the heck out here. I'm barely interesting. So, you know, this is a metal plate here, and behind it is a plastic sheet or a mica sheet, and you're just compressing it. But as I turn the screw right now, what is moving is the mica or the plastic sheet is moving in behind this metal plate. I'm not moving the metal plate. And that's what's causing that. Well, if there is an effect there, it's extremely minor. I really want this thing to peak up, with this screw driven in. I'm going to drive it in tight. Okay, I'm going to back it up. So that's comfortably, roughly the half of the range of this thing. So I'd like to make the radio front end peak here. There's probably a peak in there somewhere, but it's not on the tuned frequency. So I want to see the peak of the front end. I want to see the peak of the front end. And I am now going to set about trying to make that happen. Good luck to me. Okay, so what I've got set up here now, I've got the scope. I've done something I don't usually do. I'm listening to the speaker on the scope. So this is showing what is coming out of the speaker right now. All that stuff there, I think that's a hum we can't hear. I don't know what to make of it, but we can ignore this multiple track here and pay attention to what we're going to see in a moment. So that's what the scope is showing. A sweep is sweeping the entire AM band from 500 to 1650 or something like that. And you need to see where the radio is actually tuned. So I'll turn the volume up and we'll see something on the scope of interest. And that's this peak here, of course. So, hey, let me see if I can just fix that. Fix the image there a little bit. Okay, so one of the reasons I don't like to use the speaker for this kind of stuff is we have to listen to it while I'm doing it. So unfortunately, we're going to have to listen to it. But you see the peak happening right here. I'm just going to tune the radio. There, and you see the peak moving along. So what is that peak? I'm just tuning the radio outside the range of the sweep. Oh. So what's happening there is I'm picking up extraneous signals from the just picking up extraneous signals while I'm tuning through. This sounds like a loud, strong signal, but I guess it really isn't, because the noise is causing the AVC to quiet the radio, and we're hearing this buzz go down with it, like that, like that. So here's a noise signal. It's got no modulation with it. I just saw that light flick on and off again. Could be that tube is failing. So now we want to ask this question. Is that peak that we see on the scope here in the right spot? And I don't think I have this set up quite correctly for that. We're looking kind of at the peak of the whole radio. I think that's how I would view this. Okay, I don't know. Something keeps cutting out on this radio. Ooh. So we really want to look at what's going on here. So I'm going to take a wild shot, put the scope right on here. Whatever that's happening doesn't seem to be sensitive to vibration, or I'd be whacking this thing with my stick already. In this case, I think when we're looking here, we probably want to look relative to the chassis. I think. Let's try that first. Already introduced a bit of a hum. Just a long shot right on here. Oops. Okay, let's try this whole thing again. It's clearly affecting the radio's operation here. Okay. What do we got on the screen here? Let's take a look. Oh, that's a much more interesting look at things here. Lots of interesting stuff on here. It's a fantastic pattern right through here. Beautifully symmetrical. Very hard to see. Maybe you can see right just beyond my fingernail there. You can see it more down here. There's something happening right there. And similarly, there's another one on here. Very hard to see just past this graticule line. Don't know what those are. Tune the radio, see what happens to this thing. Oh yeah, that's interesting. Oh, just... This is getting wider as I tune the radio. I'm heading towards the peak of this circuit, but never get there. Now the reason it just went quiet is it's outside the sweep range. Let me adjust the sweep range. Okay, hang on. Big change. Okay. So lots of things happening. Get this up in this area. When I tune the radio up this way, this thing becomes very, very foggy and fuzzy. All foggy, fuzzy. So, you know, these are effects I've never seen this kind of stuff before. I don't know what to make of this. So those funny little fence post lines, one there and one there, they travel with it. Wow, it's almost like I'm turning a focus control on this. Especially up here. You can hear that change too. The interesting effects here. Goodness knows I have no idea what it means. The radio's still receiving signals on the antenna too. So how can this help us now? How is this going to prove? I don't think this is going to help too much. It's very difficult in this kind of setting to determine exactly what this frequency is. It can be done. I need another signal generator to get on top of this. I can do it. But maybe we can look at it more directly on the SDR than this way. So I'm going to stop, get the SDR radio going, and we'll see what we can see on that. Okay, I think this is going to work out. So now I have connected my, this looks like a scope lead, but I'm using it actually as the input to the antenna of the SDR, which is just in my shop. It's just, I've got it fixed right here. SDR radio is sitting right there, by the way. I don't think we have to listen to it anymore. Now if I tune the radio, we'll see a couple things happen. You're going to see the local oscillator move, and you're going to see the front end tuning move, which is exactly what I want. Here we go. So just in case you're not sure what I'm up to here, this is the local oscillator signal coming out of the radio, way up here at 1777. 1.77 megahertz. And this is the front end tuning peak right here. It's not terribly sharp, is it? Now let's think about this. The radio is currently tuned based on the local oscillator. Be tuned to 12, what would that be? 1210 or 1220 or something like that, I would say. What happened there? Something, oh, my clip lead popped off. Made a run for it. the ground wire kept them from making it all the way out of here. It's probably been talking with my cats. Probably in here at night talking to my equipment, making plans. Hey, I can get you out of here, man. All the cats have to offer is a trip to the garage, and you know that's no great thing for a radio. So don't listen to those cats. Okay, so we're back on again, and on the pointer we're tuned to about 13 or 12, 14, about 13,500, 1350 rather, 1350. But on this chart, 1350 is way the heck up here, showing the tuning peak to be way low from where it needs to be. I've just kind of picked a random spot to check this. Let's go down around 600 and just take a look at what happens. We just kind of look at this dial here and watch. So, okay, so we're 600 on the diamond, and the peak has shrunk way off. I think it's sitting right here now. About 540, and we're tuned to 600. Oh, it's missing the mark because 600's up here. There's no boost. Okay, so leaving it just. I'm not going to leave. I'm going to turn this up to 1,000,000. That's a nice round number. That's going to give me a bigger peak to look at. So we're tuned here. Okay, so if we're tuned at 1,000,000, then the local oscillator should be 460 above that. 1460. Let's see. 1440. Did I calculate that wrong? Maybe I did. So we're trying to tune at 1,000,000. I want the local oscillator running 460 above it. That's 1460. But it's actually at 1440. So regardless of what this says, this radio is actually not tuning. Let's make it tune 1,000,000 regardless of where this is. So I need the local oscillator to be 1460. Where's 1460? There's 1460. So the local oscillator set to 1460. The IF tuned to, I hope it was 460. That should mean the radio is actually attempting to receive 1,000,000. So where is the peak? Wow, it's quite clear now, isn't it? The 1,000,000 is here, and the peak on the front end is way down here at 900. It's way off. Okay, so using this setting, I will now try to turn the trimmer screw, and we'll see where we can move that front end peak. See if we can move the front end peak. Okay, so I didn't see it move one bit. As I loosened this off, now we're going to tighten it down. Oh my gosh, I don't see any change. It's cranked in as tight as I can do it. Wow. So either there's a false test, I'm not seeing what I think I'm seeing on the either I'm not seeing what I think I'm seeing. The test itself has somehow robbed this adjustment of its ability to adjust anything. I can't imagine that. Or this adjustment just is doing nothing. Well, it's not doing nothing. I could hear the effect of it. No, you know what? I could barely hear the effect of it. So maybe this really isn't a case of it kind of being out of range. Maybe it's a case of it's not doing anything. The capacitance this is adding is gone. It's just not adding much. It's got no capacity anymore. How can that be? It's a pretty simple device. It's just two plates with a dielectric in between being squeezed. The dielectric has lost its effect. Jeepers. How would I ever know that? Never heard of that. Looks like a pretty stable material to me that's in there. Is it damaged in some way? It's all there. pause. Is it something about... so what are we actually resonating against with these? Resonating against this coil, I think. I'm looking to see if the peak on the SDR, which is right around 9, I'd make it out to be 910 or so. If that's affected by anything I can do to the antenna, in terms of its location, not in terms of its strength. Just anything. Just try anything. Touching the plates of the actual capacitor. That does something. Piled in a pile of noise, I bet. Well. Okay, so I think I've assessed this. I'm convinced that there is a problem here. I'm not convinced it's this capacitor itself. I don't know what it is. It looks like too much capacitance here. I can't open this enough. Is it possible it's the other way around? That in fact, I can't close it enough. I can't get enough capacitance here. It's easy to increase this. Just add a little bit. Should take a look at this on this. Let's take a look at this on the schematic and just see if there's something I'm not getting right. Okay, here we are. So we're fiddling around out here. Let's look at the connection to the tuning capacitor. Just unsure of the symbols here. Which one is the actual tuning capacitor? Probably this one. Let's see, trimmer. Yeah. So this is a trimmer, and this is the tuning capacitor. Let's see, where's the local oscillator setup? Tuning capacitor, yeah. So this trimmer doesn't seem to have enough to do it. Or too much. It's too much. It's already too much. It's already too much. Well, too much. Or something's happened to this loop. Oh my gosh. I wonder how I can isolate all this away and just fool with this part here. Pretty easy. You turn the radio off and you can still fool with this. Right now the SDR is connected right here. SDR is watching what's right on the grid. Hooking up the SDR has changed the capacitance of this circuit to some degree. This is not a lot of capacitance here, so a little bit of added stuff will have an effect. A little hard to see that because in disconnecting the SDR we lose the ability to see it. I mean, this is the essential problem with doing these kinds of tests. When you hook up the test equipment, the situation changes, and you really can't tell at that moment that that's what's happening. Easy to be fooled. Oops. Well, I know a way. I can change the impedance of the probe I'm using. It's on times 10 right now. I could set it to times 1. That might... Well, that shouldn't hurt the SDR. This is just an antenna signal. The SDR should be able to take it. I could do that and see if that causes the peak to move around, then I know some of the problems with the testing approach I'm taking. Nothing spectacular here. The antenna itself is independent, so it's kind of funny. I'm using a coil right now to drive this. I'm actually driving the square one in here. But I couldn't really hook up my signal generator right to the antenna and use this coil. to drive the swirl. It'll be pretty much the same thing. Okay, there's not much more to see here. Okay, I'll try that. I'm gonna switch this to ×1. My radio's gonna go nuts. Well, it didn't go nuts. I had the speaker on to the SDR. Let me turn it off. So what in heaven's name has happened here? The peak, is that the peak now? I'll tune the radio. We'll be able to spot the peak, if it still exists. Tuning the radio. Okay, so lots of funny stuff has started happening here. So the lines you see going back and forth and all over the place, peaks wandering around up there as I tune the radio. I think it's an SDR behavioral thing, I'm not sure. As for the peak, which, unless one of those lines has become the peak, I see zero peak moving. You see the local oscillator on the right side going back and forth. And these other things, these blue lines have blue on my screen. I think they're blue on yours too. I think those are artifacts. If you look down around the 400 mark, let me put this full screen here. Hang on a sec. Get a better view. So down in here is the 460 area. This is the IF of the radio, and you can see I got the sweep starting just after the IF. It's starting right in here. But if you watch what happens in this area as I tune the radio, it's kind of interesting what it does. Now, you know what? It's not so interesting, is it? Lots of little things moving around all over the place. Yeah. Okay, so it's a polluted test. I'm going to go back to this setting. Notice the radio came to life. We can hear the radio better because before I was draining the signal right out of the front end. So I think I've taken this curve and flattened it, and whether it moved around, we'll never know. So that just didn't help. The ×10 thing is too much. So how can I lighten this? I can lighten this by putting a resistor in here and lighten it. Yeah, that's right. Let's get one here. How about this guy? Resistor capacitor combination I set up for something else. Nice big resistor. Okay, so unfortunately we're going to lose the display. We'll see if we can see it again here. Okay, I see something there. Now that peak is centered on, I would say, 740. I'm going to take this off and look now. That peak is located around, it's exactly the same, 740. So what I'm trying to do is I'm trying to prove that using the SDR is showing the front end peak in the right location, and it's not being thrown off by the test I'm doing. And it looks okay, actually. The radio's tuned to 800, and the peak is showing up, yeah, it's consistent, about 50 kilohertz low. So I have an option here. One option is to accept the peak for where it is. I can't move it. Adjust the local oscillator so the recovered signal is in the peak of the front end, if you know what I mean. I didn't say that very clearly. And then push the pointer to where it has to go. So it makes some sense. And cross your fingers and hope that the tuning is relatively okay. But does anybody really care? Really? It's my radio too. So maybe we'll try that. Let's try that. That'll be the last thing. So the objective now is to push the local oscillator until the radio is tuning in the range of the front end. I'll tighten this screw down a little bit. And I know it has very little effect on anything. Okay, we'll do it like that. I wonder if the fact is that these trimmers just lose it. Well, that would explain why all these radios show up. Many of them have shown up with this exact same situation. I don't know. By now, many of you are typing comments. By the way, although I don't avail myself of the comments too much, I appreciate the fact that people are loading comments on the videos, even some critical ones about what I'm doing, and having some kind of discussion about what's good and what's bad. You know, there is no right way to do this kind of work. And every one of us has different bench, different equipment, different experience, and a different radio. So, you know, lots of different there. And with that, I've kind of lost track of what I'm up to. Move the local oscillator to where the radio is tuning. So first we'll figure out where the radio is tuning. We'll do this in the middle. Let's do it right in the middle. Right there. Right between these two things. That's pretty much, that's got to be 900. So that would mean if the radio is actually trying to receive 900, the local oscillator would have to be at 1360. When we look on the SDR and we see the local oscillator is very close, 1325, but it should be up here. But that doesn't matter because we're going to move this to match this. What we need to do is figure out where the peak is here on this. Now, there's a nice curve in here, but these noise signals come shooting through it. And so you can't just say, well, this is the peak, or this certainly isn't the peak here. It's somewhere in the middle here. Let me tune the radio around a little bit and just get a look at it. Okay, so if I were to declare the peak being somewhere, I would say I lined it up right on this guy. 1778. You can call it 1780. 780. Okay, so the front end is looking for 780. You gotta make the local oscillator do the same thing. So to make the local oscillator make the radio tune 780 through the IF would require 460 on top of 780. Oh my god, the arithmetic is too much. 80, 60, 40, 1, 5, and 7, 12. I don't know why I just calculated there. It felt really good while I was doing it, but towards the end there. Now I have a calculator in here for just these situations where I just can't muster the brain power to add a couple numbers. Let's start again. 780. 780 plus 460. I think it's 460. 1240. 1240. The local oscillator should be running at 1240. I'll mark 1240 now on here. 1240. So this red line is at 1240. The local oscillator is way up here. I need to push the local oscillator from here all the way down to here. At that point, the radio will start trying to tune right in here. That's my theory. Okay, local oscillator adjustment. Can we get there? Wrong way. Oh my gosh, there's no way. This is tight. This one's in all the way. This one's out all the way. Well, that whole concept didn't work at all. So basically, I can't make these things overlap properly. I can't get these to align. So what if I tune the radio? Well, that's stupid. If I tune the radio, I'll be tuning the front end at the same time. Again, that front end just will not move. Well, very interesting. Now, what are the chances that this whole thing's gone wrong because I've got this hooked up? So this might be sensitive enough to pick up the front end response just through proximity. Let's try that. Take this off. Put that on sensitive. Not even a loop or anything. Just poking it around here. I've actually found sometimes you get right between the plates and the... No, I'm not seeing anything. That did not work. So we will try a pickup coil. Pickup coil. This is on one. Nothing at all. Nothing working this way at all. And you can even see the local oscillator on there. I got another approach. Another approach just came to mind. Okay, another approach. Pass a signal through the tuned point that we can see. Measure what the tuned point actually is based on the frequency you're passing through it. That's my theory. So we can see that hooking this up is having an effect on the radio. That's really having an effect there. Oh, this is on 1. There we are on 10. So what I'm going to do now, I'm going to leave the sweep going. I have to have the sweep going to see that image, to see that curve. I'm going to add in now another signal generator. We've got enough clip leads to do this. Okay, another signal generator coming into the picture. Now, the sweep is just inductively connected. I'm going to put this right on this antenna extension here. And I got to ground this. I believe the chassis is the place to go with this. Not the B minus. Okay, well, we still see the peak from the sweep. That's good. Now, next objective here is to dial this guy along until we see something happening on the SDR. What are we going to see? I don't know. Let's see what we see. Anything moving. I'm thinking if we pass this signal generator through the front end of the front end. Can I do this? I can. Right there. If we pass it through this, we will see it appear. And we think that peak is around 750, 800. So we're at 13 here. Let's go down there. Let's go up there. So starting at 400 and going up. Watching carefully for any crazy thing to happen here. Where are we? 530. And where am I heading? To almost 800. So I got a ways to go here. Let's get up there. Okay, up in this range. Oh, there it is. You can see it's drawing a line on the waterfall now. I'll wiggle it. You can see it with that wiggling line going back and forth. So this gives us the ability to measure the frequency quite accurately now. Assuming, where's the peak? Let me tune the radio to spot the peak exactly. Try to spot it. I would say the peak is, I think, is right on the frequency that I'm sending over. Yeah, so the peak is quite visible now, so I'll put this right on the peak. There it is. So the front end of this radio is tuning right now with this guy attached to 780 plus 2, 782. 782. How does that compare with what? It's the same. I didn't need to do this actually. 780. Okay, so everything's kind of adding up. So I'm gonna. What am I gonna do? If I disconnect the sweep, why can't we hear this other signal generator? It could be because the sweep is going through. So here's what I'm gonna do. I'm gonna kill the sweep here. We're still not hearing this. No, that's because the local oscillator is sending a different signal into the IF from 780. That's why I can't hear it. And where is it actually? Ooh, doesn't that sound horrible? Okay, so that's probably because the signal generator is connected to the chassis down here. That's probably why it's making that horrible, garbly thing. But that doesn't matter. We can still figure out 850. 850 is just way off the tuning peak. Wow, so this radio seems to have a problem that I can't easily get around. Perfect. That's perfect. So I probably won't post any videos for a couple of days because after all it's Christmas, and that'll give me some time to look into this question, because I think this is a general question and there's got to be people talking about it somewhere. I've encountered it many times, and I'd say I've just written it off in the past. That's great. That's good. That's good. Even though I don't have a solution to the problem, I think I understand the problem really well. I think. That's great. So I'm going to go away and enjoy my belief that I know what I'm doing and enjoy Christmas. So, Merry Christmas to everybody, and see you probably after Christmas.